Okay, so you've probably seen a magic square before, right? But what if I told you that the one thing everyone recognizes about it is actually hiding its biggest secret? Today, we're going to uncover the hidden mathematical power of that one little square right in the middle.
So here it is, the classic 3 by 3 magic square. You know the drill. It uses the numbers 1 through 9, and the cool thing is, every row, every column, and even the two big diagonals, they all add up to the exact same number. In this case, it's 15. That's the magic part, right?
Yeah, people have been playing with this puzzle for ages. But here's the kicker. What if there was a rule hiding right there in plain sight that works for every single 3 by 3 magic square, not just this famous one? Well, that's exactly what we're going to find out.
All right, so to get to that universal rule, let's just make sure we're on the same page with a couple of basic terms. It'll be quick, I promise. So, first up, what is a magic square? It's really just a grid. We're looking at a 3 by 3 here, where any line of 3 numbers you can draw horizontally, vertically, or diagonally adds up to the very same total. That's it.
In that special number, the one everything adds up to, that's called the magic sum. So for our classic 1 through 9 square, the magic sum is 15. Simple enough.
Okay, now for the fun part. To find the real secret, we're actually going to have to break the rules a little bit. It's time to go beyond the classic puzzle and see what's really going on under the hood.
We're going to strip this puzzle down to its absolute core. So forget that whole 1 through 9 no repeats thing. From now on, you can use any integer you want. Positive, negative, even 0. You can repeat numbers, go crazy. The only rule that stays is the big one. Every row, column, and diagonal has to add up to the same magic sum.
By getting rid of all those extra rules, we can finally see the puzzle's true skeleton, its pure structure. And it turns out, the key to the whole shebang, it's been hiding in one very special spot this whole time.
Okay, let's get a little algebraic here, but don't worry, it's easy. We're going to give these boxes some names. A, B, C, you get the idea. But the one we really care about is the one smack dab in the middle. Let's call that guy M. And that magic sum we keep talking about, we'll call that S.
And this is where it gets really interesting. This is the big question. If you found any magic square anywhere, and you could only see one number, the number in the very center, what could you actually figure out from just that? Well, as it turns out, you can figure out something massive.
All right, let's crack this thing open. We're going to walk through the logic step by step. And what you're about to see is how those super simple rules we talked about reveal something incredibly elegant and powerful. Okay, first, let's look at the two diagonals. We know each one adds up to S, our magic sum. So what happens if we add them together? Well, S plus S is 2S. And what numbers did we just add up? We got the four corners, A, C, F, and H. And we used the middle number M twice. So you could say the four corners plus 2 times M equals 2S. Make sense? Okay, hang with me. Now let's do the exact same thing, but this time with the top and bottom rows. The top row is S, the bottom row is S. Add them together, and you get 2S again. This gives us this equation right here.
Now this is the clever bit. We have two totally different looking equations that both equal 2S. What does that mean? It means they have to be equal to each other. So let's put them side by side. You see those corner pieces, A, C, F, and H? They're on both sides, so we can just poof, cancel them out. And look what we're left with. It's so simple. B plus G minus 2M equals 0. Or, in other words, B plus G is the same as 2M.
We are so close. Look at the middle column. It's B plus M plus G, and that has to equal S, right? But wait a second. We just figured out that B plus G is the same thing as 2M, so we can just swap it out. Instead of B plus G, we write 2M. And that leaves us with 2M plus our original M equals S.
And there it is. S equals 3M. The magic sum is always, without fail, 3 times the number in the center. This isn't some weird coincidence for one puzzle. This is a fundamental law baked into the very structure of any 3 by 3 magic square you can possibly create. How cool is that?
Okay, so that's a seriously powerful rule. But what can you actually do with it? Well, let's put it to the test. I'm telling you, this formula is like a secret weapon for solving these things.
All right, check this out. We've got a mostly empty square. The only clues we have are that the center is a 7, the top left is a 10, and the bottom middle is a 9. At first glance, this looks impossible, right? But not for us. Not anymore.
Thanks to what we just learned, we have a killer 3-step strategy. First, we find the magic sum using our brand new S equals 3m rule. Second, we use that other little secret we found along the way, that any two numbers opposite each other have to add up to 2 times the center. Once we have those, the third step, filling in the rest, is a piece of cake.
Let's do this. Step 1. M is 7. So S, our magic sum, has to be 3 times 7. That's 21. Boom. Every line adds to 21. Step 2. Opposite pairs. They have to add up to 2m, which is 14. So what's opposite the 10? It has to be a 4, because 10 plus 4 is 14. What's opposite the 9? It's got to be a 5. And just like that, the whole puzzle just unravels. The rest is just simple arithmetic to make every line add up to 21.
So what have we really learned here? The big takeaway is that a magic square isn't just a random jumble of numbers that happens to work. It has a deep, predictable structure, and it's all built around one single powerful relationship.
And this quote really nails it. The center isn't just another box. It's the structural heart of the whole thing. It's the anchor that dictates what the sum will be and how all the other numbers have to behave. It really is the key.
And get this. This relationship is so fundamental, you can actually describe any possible 3x3 magic square with a template like this. See how every single box is defined by m, the center? You just pick a center number, m, and then 2 other numbers to create some variety, and presto, you can generate an infinite number of brand new, perfectly valid magic squares.
You know, we started this whole thing just by proving that the center number holds the key to the magic sum. But what we ended up finding is so much deeper. The center is literally the heart of an infinite number of possibilities. It really makes you wonder, right? What other simple games or puzzles that we see all the time are hiding these beautiful, elegant patterns, just waiting for someone to look a little closer? Something to think about. Thanks for joining me.